All right, so here we are with our Toyota Corolla data, and I want to show you a relationship in the data, and we'll notice right here that we have central locks, and then we also have power windows. And if you have central locks, for the most part, you have power windows as well. And so there's a relationship between central locks and powered windows. And let's see if we can find any that are not having powered locks. So here's the central windows, and it also does not have powered locks. And so basically, if we know one of these, we pretty much know the other. Here's an example of central lock, and then it also does not have powered windows. And we can look down here and we can see some more examples. Here's one where it's not the case. So this one has central locks, but it does not have powered windows. And so you can see that for the most part, when we have central locks, we also have powered windows. There's a few exceptions, but that's the case. Now, we can discover that by looking at the data. Now, if we put both of these in our input model, they're going to be very highly related, and it's going to be almost like telling it two input columns that have the very same information. Another way we should discover this is by looking at the correlation matrix. So we can take all of our numeric variables and analyze them. So let's analyze them and go into multivariate methods, multivariate, and let's create a correlation matrix. So we will take all of our numeric information and we will put it here in columns, in our Y column, and have a look at it, and then there is our correlation matrix. And if you look at this, you'll notice that central locks, so here is our central locks. You'll notice that it has a 0.87 relationship with powered windows. So if I get over here, then here's powered windows, and then here's central locks. And so we have a very high relationship, a very strong correlation between these two variables. If we put both of those in the model, it will confuse the model. So what we want to do is we want to eliminate one of these, and the way we can do that is we can see which one of these has the strongest correlation with the outcome variable. If we go over here, we see that power windows has a 0.356 relationship with our outcome variable, and up here we can see that central locks does not have as strong, it's just a little bit weaker. And so we're going to go and remove that. We'll remove central lock and not include that in our data when we're doing our modeling. It's okay if we have strong relationships between our predictors and our outcome variables here, and we do have some. Here's a strong negative relationship between price and the age and the years. But if we get out here and we have either a strong positive or a strong negative correlation, anything that's 0.75 or greater out here, then we should figure out which are the most important and the strongest relationship to the outcome variable and eliminate the other. Now, looking through the rest of these, none of these look like they're greater than 0.75 or stronger than negative 0.75. So it looks like that's the only collinear relationship that we need to deal with. So we know that we need to get rid of central locks when we're doing our modeling.